Hello, good morning, good afternoon, good evening. Welcome again to yet another fantastic workshop. If you do not know my name is Feiji. I am the Community Programs Manager here at Andela. And as always, bringing you great content, great workshops, so you could level up your skills and, be great in the tech space. I'm based in Lagos, Nigeria. I'm curious to know, where you are joining us from. So please pop in the chat. I always love to see new names, new faces, although I can't see your face. I love to know and learn who's, joining us today. If you joined our workshop last week, I'm sure you must have had a great time. And I'm curious to know how many of you were here last week when we had the Understanding Work Velocity with clients. Please pop in the chat, please. And don't be shy. All right, I see Aikumu from Lagos, where I'm based, Douglas from Kenya, Nairobi. That's great. And while you're popping in the chat, you could also let us know what you're looking to learn today. What do you want to get out of this workshop? Let us know in the chat as well. Uche from Lagos, welcome. Wow, Abubakar from Birmingham. How is Birmingham doing this fine day? It's actually a fine afternoon in Lagos. So I'm hoping you're having a great day as well. All right, just before we jump into the workshop, I'd love to say that we are going to be starting a learning series starting this month, actually, in the next couple of weeks, focusing on Azure, and we'll be, sharing that information to you as we, progress by next week, actually. But that's not what we're here for. We're here for multimodal search using Google Cloud's AI tools. Now, we know that AI has taken over, the tech ecosystem. Everyone is talking about it. Everyone is trying to jump into the bandwagon. And we are here to actually equip you with some information and hope that this helps you, start learning and upskilling on, all things AI pretty much. And if you have, suggestions about, the type of workshops we could bring to you, please let us know in the chat. All right, so today we're going to be speaking on multimodal search using Google AI tools. But first, we are going to, just run through the agenda. We're going to start with large language models with vision. So how are we bringing large language models intelligence to images? And multimodal search, how does it work? Like, what is multimodal search? How do you use it? And then David, who's our speaker, is going to be showing you live how to use multimodal search on Google Cloud. And then we'll have time for questions. Okay, so if you look at the panel below, you'll see the chat function. You'll also see the Q&A function. So please click on the Q&A tab such that you can ask your question as we progress. And we'll take this right at the end. The workshop is going to be for about 40 minutes. And so we should have time to take your questions at the end. Now, who's our speaker for today? David is a seasoned data engineering leader. He has over 16 years of working experience, and he holds multiple Google Cloud certification. And he's been recognized as a Google Cloud champion innovator. He's currently working at a stealth startup as a VP of engineering, and he has a portfolio of so many events like this. His teaching stints at the University of Chicago, amongst many other, schools, has actually, just highlights his dedication to, education and mentorship. So at the end, David is going to share his profile. He's going to share how you could connect with him because he's really big on community. He's a community leader, and he has founded the Data Engineering LATAM community. David is based in Peru. So you can connect with him, right after, this workshop. So I'll love to stop share now and, welcome David. Hi, David.
Hello, can you hear me?
Yes, we can, loud and clear. Welcome
Nice.
to this workshop. I'll let you take it away. A lot of people are already excited to be here. We already have, questions. And Ebenezer, yes, the session will be recorded and will be shared with you right after this call. So yes, you could take it away, David. And thanks for being here.
Uh, it's such an honor to be here with you guys. So, without further ado, I'm going to share my screen. Please confirm if you can see it. Can you see my screen? Yes or no, it's okay. Yes, thank you, thank you. Okay, so today we're gonna be talking about multimodal search using Google AI tools. Okay. The agenda, it's all about LLMs with vision, bringing LLM intelligence to images. Then how does multimodal search work, and a live demo. At the end, there will be time for questions and answers. Well, that's me. Actually, that's an AI representation of me. I think it looks okay. Okay. Bringing LLM intelligence to images. Have you ever thought about how Gen AI and LLMs could be used to organize your enterprise image data? You may be wondering, we have millions of product images. How to use LLMs to understand their meaning, just like humans, and build a smart search and recommendation system? Or can we use the LLM intelligence to find anomalies in product inspection images in factories or security camera images? Well, here's a quick solution by combining multimodal embeddings and vector search. What is that? How does it work? Let's see. What if large language model had vision? I think we all have heard before of large language model. Things like GPT, GPT-4, Gemini, Hema, Llama, all those are LLMs. I think one way or another, we have interacted with an LLM. In this case, this is an example of um, how to do a search just by text, and this this application is um, looking for their meaning, not keyword search. It's just it's called semantic search. Um, how how does an LLM perceive the world? You can experience by yourself in this demo, and I'll share the link at the end of the presentation. And in this case, this is Mercari text to image demo. You can enter a query to find items. For example, a query for handmade accessories with black and white beads returns the following items. Search from 5.8 million Mercari product items in milliseconds. Please note that this demo does not use any of the item titles, descriptions, or tags for search. The results are retrieved by looking only at the item images with a large vision language model, a specific type of multimodal model. Multimodal model can process and generate information from multiple modalities such as text, images, and audio. a query result for cups with dancing people. The process involves importing 5.8 million item images from Mercari into this demo, followed by the extraction of multimodal embeddings using Vertex AI multimodal embeddings. Vertex AI is a suite of services from Google Cloud. A search index was then built with the embeddings on Vertex AI vector search, establishing a robust foundation for efficient and accurate item retrieval. About Mercari, this is a well-known marketplace app with over 50 million downloads in the United States. The key enablers for these solutions are: number one, the embeddings generated with Vertex AI multimodal embeddings, and number two, fast and scalable vector search by Vector AI vector search. Let's start by taking a look at these technologies. One of the most powerful applications of deep learning models is to build an embedding space, which is essentially a map of meanings for text, images, audio, etc. For example, with an image model, images with similar appearance and meaning will be placed closely together in the embedding space. The model can map an image to an embedding, which is a location in the space. Therefore, if you look around the embedding, you can find other images with similar appearance and meaning. This is how image similarity search works. The result is a vision language model, which can build a shared embedding space for images and text with a fixed dimension organized by their meanings. In this space, images and text with similar meanings are placed close together. This means that you can search for images based on text to image search, or search for text based on images, image to text search. This is the basic idea of how Google search finds relevant results across images and text. With the innovative aspect of the recent VLMs, vision language models, is not only their capacity to search across images and text, but also their librarian level LLM intelligence in organizing them for various business use cases without any effort for collecting industry-specific datasets nor additional training tuning. This was almost impossible with the image-only deep learning models of the past. How do the VLMs, vision language model, perceive the world of images? With a multimodal embedding space of 3 million Mercari item images, Nomic AI and Google have created a visualization demo that allows you to explore the space. This is what that demo is all about. The images are sorted into an extremely specific categories, providing a glimpse into the complex way that model understands the images. With e-commerce or marketplace services, sellers can upload an image of the item they want to sell. Then the service will search existing items with the same category or brand or similar colors and styles. Using the Vertex AI Gemini API, the service can generate suggestions for the item name, description, and sell price based on the information it finds. This can significantly reduce the effort required for sellers to put articles on the market. Buyers can enter a natural language text query to find items that match their general intent rather than just the exact item name. How about security monitoring? LLM's insights can make security monitoring such smarter for security camera images. Even with thousands of security cameras in the field and millions of monitoring images incoming every minute, you can still watch for images that match text queries like a person trying to open the door, the water is flooding in the factory, or the machines are on fire. How about autonomous driving? Autonomous driving manufacturers store vast amounts of images and videos, which they use to train their vision recognition models. It is critical for them to organize and retrieve these images quickly using complex query conditions, such as a crossing road with red lights on and pedestrians are standing, or a crashed car stopping in the middle of the freeway ahead. For the model development and verification, they can use natural language queries to find relevant scenes from millions of images instantly, even without any tags or labels attached on the image, significantly improving their productivity. The machines are on fire. Okay,
So,
so yeah.
sorry, I just wanted to cut you there, David. So thank you for taking us through that. Before you jump into the demo, we have a, will I say, variety of, audience on here with, technical knowledge. There are some people who have, over 15 years of working experience like you do. Others have maybe less than 5 years or 3 years, and they're looking to start. I'm well aware, and we had a chat about this initially, about, the background knowledge that, someone should have before jumping into this. And I know that you had, mentioned quite a few skills or stacks. So I wanted to just jump in here to, ask that question, one, and two, if, I know that there are a bunch of resources for those three industries. You mentioned e-commerce, you also mentioned autonomous driving, and so you mentioned quite a few. Where is, and I also think I picked up on Gemini API. What would be your, recommendation for people to, get started in, exploring more on this, especially for clients that they're working on with, rather? I know I asked a variety of questions on there, but yeah.
What if I want to start a career in AI, search, multimodal search, LLMs, VLMs? First, what I will do is to start coding in Python. I think in the past, Java or R were like the main programming languages for doing big data or data science. Today, Python is like the standard for develop this kind of applications with machine learning, deep learning, all things AI. So what I will suggest you is to practice. Practice. What is Python? What can I do with Python? How uh, can I interact with APIs using Python? there are a bunch of APIs like the ChatGPT API or Gemini API, Llama API. Everything today is an API. If you learn how to code and code well, and then you add on top of that how you interact with this kind of models using the API, you're almost there. It's not that difficult. I think the difficult part was to create those models. Okay, but that thing is already done. You don't have to reinvent the wheel. So get well versed in Python coding using APIs, and the rest is learn how to go to documentation for the ChatGPT, for Gemini, and so on.
Perfect. Thank you so much for that. I'll let you delve into the demo now, how you showed this. And I just want to also just mention, please, for people like me, I have 0 years of, technical experience. So as you go through the demo, I don't know if there are others that are new to AI or new to multimodal search. Please ask your questions in the Q&A panel below. If you didn't quite follow, there'll be lots of, time for questions. But David, be mindful of people like me who have no idea like what this is all about. So thank you. So I'll let you take it away.
Sure. I'm going to now share a little demo. So bear with me. Okay, what we have here, it's called Google Colab. You probably have heard before of Jupyter notebooks. Notebooks. This is the notebook on the cloud. It's free to use. Okay, so with this web interface, you can interact with APIs. You can develop your codes, like we are going to see. On the left part of the screen, we can see like the contents of this notebook. We are going to be talking about text embeddings. I think multimodal embeddings has its own way of how you should use them. I think this example is more like more easy to follow. So in this notebook, we're going to see text embeddings, project environment setup, use the embeddings model, similarity from word sentence embeddings, get sentence embedding from the model. Okay, first, you need to install a library. You have to run this command, and you get a library so you can follow the next cells. A notebook is a set of cells. This is a cell. In a cell, you run codes. There are a bunch of cells. There are two types of cells: cells for codes and cells for text, like this. Okay, so now I need to authenticate this notebook with my account for Google Cloud. I'm doing that right now. Now that that is linked to my account on Google Cloud, I can enter a project, a region where I want this code to run. Here I'm importing Vertex AI package and initializing that part. Here, please take a look at this part. This is a model. There are a bunch of models here. And this particular one is text embedding model. What this thing does is to take a string, like a bunch of words, and return the embeddings. We're going to see that in a bit. Let's say, for example, that I want to transform the word life into an embedding space. It's just as simple as running this line. The returned object is a list with a single text embedding object. Here we can see the length of that object. That is a list of 768 components. It looks like this: a number, another number. I'm showing just the first 10 numbers or vectors in that object. There are 768 in this object. That is how it works in this particular model. Now we can generate a sentence embeddings. This was for one word. Now, what if I want to take the whole sentence, what is the meaning of life, into an embedding space? I run the same line with different string, and we can see again the same length and different numbers. This is now we are in the embedding space. What if we want to calculate the similarity between two sentences as a number between 0 and 1? That is easy to do if you import the cosine similarity class. Here we are calculating 3 embeddings, one for what is the meaning of life, a second for how does one spend their time well on earth sentence, and the third sentence will be, would you like a salad? We have 3 sentences now in the embedding space. If we want to calculate between a pair of 2 vectors in the embedding space, how close they are together, we apply these lines, and we take the number with the highest value. Let's say, for example, we have the cosine similarity between vectors 1 and 2. What is the meaning of life as a sentence is related to how does one spend their time well on earth. It's kinda related, but it's definitely not related to would you like a salad? As we can see, when we are comparing vectors 1 and 2, we get the highest number. The lowest number will be like comparing vectors 1 and vector 3. It's like nothing to do. Now, from word to sentence embeddings, is one possible way to calculate sentence embeddings from word embeddings is to take an average of the word embeddings. This ignores word order and context. So two sentences with different meanings. So two sentences with different meanings, but the same set of words will end up with the same sentence embeddings, as we will see. Let's say the first sentence, the kids play in the park. Second sentence will be, the play was for kids in the park. If we remove stop words like the, in, for, and, is, punctuation, we will end up with something like this, a list with the first sentence. This list will end up only with kids, play, park, and the second list is composed of play, kids, and park. It's like so close together, only the order of some words have changed. Now let's generate one embedding for each word. So this list is a list of 3 lists actually. Let's run this. Oh. The thing with notebooks is you have to run in order. You cannot leave some cells without running. Okay, we got it now. Now, after these transformations, we end up only with a single embedding of length 768. That number will follow you, will haunt you if you are learning embeddings. Okay, that is for the embeddings number 1, and for embeddings number 2, we'll do the same. And let's print the average of the numbers on each embeddings. As we can see, we'll end up with exactly the same numbers after taking the average. It's the same number, even when we were talking about 2 different sentences. What happened? I think this approach is not accurate for using in a real world scenario. How you fix this is to use, as I mentioned, the calculation involving the cosine similarity. After doing those calculations, you end up with embeddings like this. Again, this vector space, this embedding space is 768 numbers for each thing, a word, a sentence, whatever that you want to apply an embeddings. This was just for text embeddings. I think it's not that difficult. It's a good place to, a good starting point if you want to play with embeddings. In this particular case, with text embeddings. So do you have any questions? All right. That's the embeddings part. This one was with text. You can do a lot more. What? Okay, we have a question in the chat. Explain what cosine similarity does. If you look for cosine similarity, it's a concept from physics that is calculating how closely are 2 vectors. Remember, what is a vector? A vector is like a line with a magnitude and a direction, okay? Okay, if we have embeddings, which is a bunch of numbers in a mathematical space, in the embedding space, we can take them as vectors. If you remember your undergrad classes of maths or physics, you will see some concepts for calculating the cosine similarity. Is mathematical concepts, but it's already the heavy lifting was already done and packaged nicely into a function in Python that you can reuse for your particular use case. So you can search for cosine similarity is something like this. Yeah, that's it. There are a lot of, not a lot, but other like algorithms or techniques for finding how closely are a bunch of vectors together. I think cosine similarity if you remember your undergrad classes, I think it's more easy to teach. It's a popular one, but it's not the only one. This is for text embeddings. Now imagine something like text and images. You have to take pixel by pixel, uh, transform it into an embedding space. The concepts are similar. Then you have to calculate similarity between different vectors. That's how it works. Got it.
Perfect. Thank you so much, David, for that. I guess a couple of people had some questions, raised their hands, about, the demonstration. I mean, I've not seen any questions in the Q&A tab just yet, but like I said, mentioned it will be recorded and also sent to you in the community space. But now will be the time to ask questions about this demonstration to David. If you have, questions about like what he just demoed, no matter how, there's no wrong question, no matter how simple they are or complex it is. And, also David has a wealth of knowledge in data engineering as well. So you could ask him, questions and, he can always get back to you if he doesn't have the response right now. So I'm going to open the floor for questions. Do we have questions? I think we have one in the chat.
Can we add any personalization with this? How so? What do you mean by that? The thing is, you have like a technique, cosine similarity. You have a way to transform text or sentences into embeddings. With that, you can build and search for your users, like in e-commerce or apps like Netflix, and you are searching movies to watch. I want a cinematic movie with great uh, photorealistic, whatever, or I don't know, with these actors, and the plot of the movie should be like this. It should be drama, get a bunch of explosions or whatever. I think if you try to search for something like all that text query, if you build your system the old way using keyword search, you won't get anything. But if you translate that text query into an embedding space, then you can find similarities between meanings. Imagine the other embeddings in this space are composed of movies, or yeah, movies. And then you can find what is the relationship between this text query and these movies, which one returns the highest value. Let's keep the first three highest values, and then you will have three results, three suggestions for your user. Something like that you can build using this.
Okay, so we have a bunch of questions coming in, but while we are on that same topic, I think Abdullah asked a question and said exactly that this is understood, but with this search, if user search response with some personalization touch and user B search response based on some preferences based on user profile. I'm not sure if that's a question or that's a comment. But first off, everyone, please move over to the Q&A tab so we could take questions. Before we, start, digging into through the chat. I will start with Solomon's question. Is this applicable to normal Pandas style data? Like, can we use this to downscale large data sets?
What? Pandas data frame is data structure for you to play with data. let's say you can have a pandas data frame with different columns. One of those columns will be sentences. You will need only that column to apply this get embeddings thing. But yeah, you can be as creative as you want using pandas data frames or lists or different data structures.
Awesome. I hope that answers your question. And then someone anonymous has said, can this be done in Azure environment with, C#?
The thing with LLMs, different vendors, specifically the big tech companies, they develop the model and then they create like SDK for your preferred programming language. In this case, this is built on Python. I think there is also options for do it with other programming languages, but I don't know. We will have to search, but I think that is possible.
So I'll take this as an action, David. And I mean, in my post, in response to this anonymous person, maybe we'll check afterwards and get back to you, anonymous attendee. Okay.
Anonymous.
Yeah, thank you, anonymous. So Tonga, I'm not sure if I'm pronouncing your name right. I'm really sorry if I didn't pronounce that properly. Thanks you for the presentation. The embeddings you showcased was text. What approach do you advise for image embeddings, and how best can you explain RAG concept?
Wow. With image embeddings, there are like another libraries, but you have to find, I think, something like how to do stuff using Google Cloud or using your favorite cloud vendor, because they already have some models or APIs for you to use. In what was the second part of the question?
And how best can you explain RAG concept, RAG concept?
RAG. I love that thing with RAG. RAG is like a system that you have to build so your LLM doesn't hallucinate. You know, the LLM was trained. Wait, the LLM was trained on a bunch of texts from the internet. Nobody knows which website was used for that. But when you asking questions about your own data, your company's data, definitely that LLM was not trained using that data, and it will it will do its best to give you an answer, but you should not rely on 100% on that answer. To avoid those like dangerous situation of asking AI complicated things specifically for your company, you have to ground it. Okay, the thing is grounded with your company data. When you do that, you are using RAG. There are specific techniques, but I think uh, from an holistic point of view, is like grounded the LLM with your own data, so it cannot hallucinate. There are a bunch of techniques. It's not like easy thing to do, but it's the recommendation for using LLMs with your company's data.
Awesome. And then if I is asking a question, what is the difference between vector databases and vector embeddings? Can you give some explanation as to why we use vector embeddings in LLM's processing?
Yeah, this was calculated on the fly, but what if you want to store this in an efficient manner? That's why there are a bunch of database vendors that provides you with those specifics for storing this type of um, embeddings. Google Cloud also has upgraded their databases with a way to store this particular kind of data. You can leverage those services as well.
Awesome. And then Martin is asking, can we use text embeddings not just for finding contextually similar text, but also for structuring a QA/retrieval system where the embedding of a question retrieves plausible answers?
The thing is, you will have to divide your problem into steps. One step will be the text query, transform it into an embedding, and then your own data, your questions and answers also should be transformed into the embedding space. Then apply an algorithm to find similarity, like cosine similarity, and get the highest number and retrieve that associated pets with that number. That will be your approach.
Perfect. And we have another anonymous who's thanking you for the presentation. Please, how can someone learn the algorithm that was used to generate the embeddings with text or images? If joining the images and text together, what multimodal techniques can be used?
I think I have another notebook for that, but it's a little bit more complicated. Okay,
Okay.
this is multimodal use cases is using Gemini API. As we can see, the first steps are pretty similar. In this particular case, a multimodal model was instantiated for the Gemini 1.5. There are a bunch of functions, like helper functions. So, okay, first part, question, then there is a prompt, you create a list, and that list, you send it to the multimodal model, and then you will retrieve your response. What if one of these components of this list is not text? Let's see an example. Let's say we have a PDF like this, and you want to ask how many tokens can the model process, which is a concept, is a part of this PDF, of this paper. So you are asking a specific question in that paper. The answer is on that paper. So you create your PDF, you send your prompt. Now you have two data types, PDF and text. You create your list like this and send it to the multimodal model, which is Gemini. And then the answer is here. The model can process up to 10 million tokens, la la la. You can do it with PDF. You can create a bunch of images. In this case, there is a prompt, this text, there is an image, this image, and another image, this one. You send a list with these three components and get your answers. What if you want to do the same but with video, like this? And you're asking, what is shown in the video? Where should I go to see it? What are the top 5 places in the world that look like this? Now you create your list with the prompt, with the video, and let the Gemini do its magic, and then you get your answer. The video shows the beautiful Antalya Harbor in Turkey. Antalya is an incredible popular tourist destination in Turkey, la la la. Okay, you can use it for images, for video, for text, for PDF. um, and then you can get crazy with your prompts, ask summarizations, ask specific questions from that video, from that image, and I think that's it. That's your question.
Awesome. I still have some questions coming in, and we're running out of time, but we'll just take this last two. The SETI says, I might have missed it, but are the APIs or the LLM and the interface you were using paid or free?
For using these models, there is a little fee, like a few cents per millions of tokens. At, you can think of a token like a word. You will have to like summarize big PDF files to get like $1 of fee. It's not that much. I think it's. I will encourage you to try it, the Gemini API. And I don't know, if you're investing in your career, try to save that money and use it for play with these models instead of, I don't know, investing on other like academics or schools or whatever. This already has the model. Now you have to be creative. What can you do with that? What can you do? What can you build on top of those models? Like a summarization app, question, a Q&A app. I don't know. It depends on the developer.
Perfect. Thank you for that. So I'm going to add, this is the last question we'll take on this topic, and I'll let you, finish up, share, the resources, and so people can connect with you because there are questions as well on that. But this last person probably had asked before. Anonymous says, hopefully I understand your answer to the question about applicability to Pandas style data. Since Pandas can load CSV and there's a CSV loader from LangChain, how isn't it applicable?
Your CSV, if it's loaded into memory in a pandas data frame, you have to send it line by line, I guess. I haven't seen it like MIME type of pandas data frame. You will have to embed that pandas or a particular part into the text component, like in the prompt, and then create your list with the contents of the pandas data frame.
All right. All right. So I'll let you take it away, share the resources that are going to be on the slide deck, so such that they'll know what they'll be viewing after the workshop. All of this will be sent, the recording will be sent, the slide deck will be sent, all the resources will be sent. So I'll let David share.
The Mercari multimodal image search demo, the notebook, a particular blog post that I recommend you to read, and the product pages are on this slide. There is a short course about text embeddings, which I encourage you to take. It's easy to follow, really from the basics. If you know nothing, don't worry. The instructor will teach you with no prior experience. You can learn a thing or two about embeddings, but basically you will learn about what is an embedding, how can you use it in your applications, how to find similarity between embeddings. Then I will encourage you to play with the Gemini API Quick Start with this resource. I will share those. If you want to follow me and I don't know, ask some questions or whatever, I'm always sharing content online. Feel free to follow me using that QR code, and that's it. I'm going to share these links now.
Perfect. Thank you so, so much, David. This was amazing. I also popped the link in the chat. That's where you could connect with, David. If you couldn't, quite get the QR code, I popped it in the chat as well. David always posts, resources. He's a seasoned, data, engineer, and he's so versatile. So thank you, David, for, sharing your time with us today. And thank you, Joel, for the compliment. So we have just about 6 minutes, but I'd love to share that, we have so much more workshops. Please, I'd love for us to react and give David his flowers for being here, spending this time with us. Thank you so, so much for introducing multimodal search to us. Really, truly appreciate your time here. And we hope to bring you back for another workshop. So if you want David back, if there are questions you have, or there's some models you'd like to learn, pop it in the chat. We'll look at this, towards the end of the call, and that would actually structure the type of events we bring to you. What do you want to learn? What do you want to upskill on? So please share, on the chat. Oladele says, thank you, David. I learned a lot. I have 0 years of technical experience, but I also learned something. So I could go out and flex that. Yes, I have some experience with multimodal search now after this call. So this was really, really good. Thank you so, so much, David. And we hope to see you sometime again.
It was an honor, such a pleasure to be here. Hopefully we can repeat this anytime soon. Okay, let's keep in touch.
Awesome. All right, guys. So that's as much as we could take. I saw questions in Azure. Like I said, I'm not technical. I don't, act like I am technical, but I love to say that we have a speaker who is coming in this month and who's planning a 4-series workshop on Azure. If you don't know anything about Azure, you are learning to, upskill on that, please keep an eye out on the channels, the event channels. We'll put in the topics that we're going to be learning. And so we'll be deep diving into Azure for the rest of the year. And hopefully, you learn something. But I see the topics on there on the chat. Yes, we'll look into this if there's more that you want to learn on LLMs. Kenneth says you'd like to learn more about the RAG concept. Please keep popping them in until the end of this call. And you could also comment on, the community space, and that would shape the series of events that we see pretty soon. But till next time, hopefully this month, I think in about 2 weeks, we'll have another workshop and you get to see me and another speaker. It will be shared on, Circle and also on Andela chat. So the recording and the PDF, so you could access those resources. It will be shared and you should get it in your email as well if you do not have access to Circle. But then you'll get it across to you. So thank you so much, guys, for being here today. Thank you for joining us, and I hope to see you in 2 weeks' time, hopefully. Enjoy the rest of your day. Thank you so much for being here.